I'm going to talk a little bit about volume, but you might first want to have a little look at my clip on area to help you understand volume. So what is volume? I guess it can be described as the space inside a three-dimensional object, and it can be very useful for calculating things such as the amount of water needed to fill a swimming pool, or indeed the amount of sand needed for a child's sandpit, or something even as simple as the volume of a tin of baked beans. How much space will this tin actually hold? That's volume. Units for volume are the units cubed, in a similar way to area, but this is shown with a little 3 to the top right hand side of our unit. That's the units cubed. Centimetres cubed, metres cubed. So what is 1 centimetre cubed? What does it look like? Well, in fact, that is 1 centimetre cubed. Each dimension on that small cube is 1 centimetre. And to put that in proportion, my little finger is approximately the thickness of 1 centimetre. Obviously that will depend on how big your hands are, but as a rough guide, the thickness of your little finger is about 1 centimetre. So that is 1 centimetre cubed, 1 cubic centimetre. What if I have a larger shape, such as this cube here? I want to work out its volume. I want to know how many of these will fit inside this, and that is volume. How do I go about calculating its volume? Well, the first thing I'm going to consider is just the surface area of one side. And from this I can see I can fit 10 columns worth of 1 centimetre across the bottom, and I can fit 10 rows worth up the side. My calculation, therefore, to work out the number of centimetre squares just on one side would be the 10 columns multiplied by the 10 rows. Now, in fact, that would actually give me 100 centimetres squared across this first flat surface. But this is a three-dimensional shape, so I'm calculating volume, so I need to consider its depth. I've already worked out that there are 100 squares, centimetres squared, on this surface. But how many slices of that can I fit along its depth? If this represents my top slice of 100 centimetres, I can actually fit 10 slices of these along its depth. So in fact, my calculation now looks like this: 10 times 10 times 10. Now, you should be able to do this multiplication, but unless you're told otherwise, you can use a calculator. 10 times 10 is 100, times 10 again is 1,000, remembering the unit, centimetres cubed. So in actual fact, there are 1,000 centimetres cubed inside this larger cube. Let's apply this to a real example. Imagine I have this cardboard box and I want to work out its volume. First thing I'm going to do is measure along here. For the sake of argument, let's say that this is 40 centimetres. I'm also going to measure along here. Again, let's say that this measures 25 centimetres. So I'm now going to calculate the area of this base by multiplying 40 by my 25. 40 multiplied by 25 is equal to 1,000. Now I've worked out area, so this is actually centimetres squared for now. Volume also considers the depth. So how many of these 1,000 centimetres squared slices can I get along this box in this depth? Well, imagine that this is actually 12 centimetres. So my completed calculation will be 40 multiplied by 25 multiplied by 12. Now I know that 40 times the 25 I've already done was 1,000. I can then multiply that by 12 to give me an overall answer of 12,000 centimetres cubed. That does seem an awful lot for this box, but when you consider that I'm trying to get as many of those into it as I can, then yes, 12,000 doesn't seem unreasonable. I can apply this theory of volume to other shapes such as a triangular prism or indeed a cylinder by calculating the area of one end of that shape and then simply multiplying it by its depth, remembering that the units cubed, either centimetres cubed or indeed metres cubed or whichever unit you're using. Units cubed. Volume. I hope that helps.